Okay, these are homework problems. Exercise 10G. We're looking at question 16. From a standard deck of 52 playing cards, how many 5-card hands can be dealt consisting of black cards only? Black cards only, there are 26 of them, and we're choosing 5. Because the order in which you're given those cards does not matter. Okay? So for part A, it's 26, choose 5. For part B, you want 3 diamonds and 2 clubs. Now, how many diamonds are there? It's a quarter of them. It's 13. You're choosing 3. And you want 2 clubs, and there are 13 clubs, and you're choosing 2. Now, the order in which you're given those cards, you know, if you're playing cards, the order in which you're given the cards doesn't matter. Whatever cards are in your hand, it doesn't matter which one you were given first, which one you were given second or third.
D, not B.
Oh, sorry, that's D. Sorry. All right, I'll go to B now. Whatever they work out to be, girls, you can work them out. Consisting of diamonds only, there are 13 diamonds. Choose 5, because you're choosing 5 cards. In C, all 4 kings. That's just 4. There's only 4 of those. 4, choose 4, which is 1. See, there's only 4 kings. Oh, you're choosing 5. I'm sorry. All right, let me think.
4, say 4, and then 52 minus
Yeah.
4.
So it's 4, choose 4 times. You can have any of the other cards. 48, choose 1 more. Okay? So 4, choose 4 is for the 4 kings. And 48 cards remaining, choose another one. Was the answer 48? Yeah, sorry, I thought we were choosing 4 cards. I've done D. E, consisting of 3 2s and another pair. Now, okay, 3 2s. There's 4 2s. You're choosing 3. Now, another pair. You can choose any other card. So we'll go, how many cards left if you've just chosen? Wait. How many cards have you got left? 49. We're choosing any other card. 49, choose 1. But now the next card that you pick has to match that. Wait a sec.
So then there's only another 3 chances of money.
Another pair, could that be 2 jacks, or does that have to be numbers? All right, so there could be 49 cards left, right? So you've chosen 1. Let's say...
So you've got 3 C.
Oh, no. Stop. No, it's not 49. I don't want to choose that 2, the other 2. Girls, 3 2s. It's 48 that I can choose from. I don't want the other 2. So 48 others that I could choose, and there'll be how many pairs for that? Let's say I chose a 5. There'd only be 3 other 5s left that I could choose from. So it's 3, choose 1. Okay, so they're my 3 2s. There's 48 cards left because I can't choose the other 2 because that won't have a pair. So it's 48, choose any other card, doesn't matter which one you've chosen, but that card will only have 3 other matching ones that you could possibly choose from. So we've got 3 out of the 4 2s. Then we've got any other card.
It's the wrong answer. It's the wrong answer. The answer's 288. That's 576.
Looks like we've got to divide it by 2. 1 sec. Because if you do 576 divide by 2, all right. 3 choose 3. Wait a sec. Any other card except the 2. And another pair. But yeah, 2 cards that happen to be a pair. Just give me a sec. I can't stop the video. Sorry, I'm trying to pause the video and I can't. Because I can't get under here. How can I move this? Not that. How do I move this tool button? I'm trying to get to the button under here. Another method. That one wasn't working. We've got 4 choose 3. That is 3 out of 4 2s. Then we've got, if you're choosing a pair, you've got 4 cards that you can choose from and you're choosing 2 of them. That's for any one pair. So any one pair would be 4 choose 2. But because we've already got 3 2s, there are only 12 other types of cards left that we can choose pairs from. So times, there are 12 sets of pairs that you could choose from. Do you get that?
Yeah, I get that.
See, we've already, the 2s are out. So we've still got the 1s, 3s, 1s, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So we could have 12 sets of different other pairs. All those other pairs, there are 4 cards of every other type. 4 1s, 4 3s, 4 4s. So out of the 4, you need to choose 2, but there are 12 different types of doubles that we could get.
If we were to get this question in an example, instead of the first
If it's worth 2, you probably get 1. I still don't know why this.
still work,
I'm trying to work out what. Okay, what's the question? Consisting of 1 pair
And 3 of a kind.
and 3 of a kind. All right, 1 pair. So 1 pair, let's do what we did before. It would be 4 choose 2 times 13. Wait, that's for 1 pair.
13? What's a 13?
Because there are 13 types of pairs. Okay, so 4 choose 2 times 13. So this is 1 pair. There are 13 different ways of choosing 1 pair. Times 3 of a kind would be 4 choose 3. That's 3 of a kind. Now, if I've already got 1 pair, there's only 12 3 of a kinds left. Because I've got a pair. Let's say I've got 2 2s. I can't get 3 2s now because I've taken 2 2s out.
Yeah.
So this is 1 pair, 3 ways. This is 3 of a kind. Could be done in 12 remaining ways because my pair is out. Once I've got 2 cards of 1 type out, they're not available now to make 3 of that type of card. We okay with that? I think this is the best way to do these rather than trying this 24C1 business. Okay, so we'll go with the second way. Yeah? Yeah. Question 9E. All right, everyone okay with 16? That one? All right. You want 3 2s, so you're okay with 4 choose 3. Then you want a pair. So you know how there's 4 1s, 4 3s, 4 4s, 4 5s. Out of any pair of 4, sorry, not out of any pair, or out of any set of 4 cards, you're trying to choose 2 that are the same. But if I just write 4 choose 2, that's only choosing maybe just the 1s that might be the same. You could have the 1, but there are 12 different ways you could do 4 choose 2. You could have 2 1s, or you could have chosen 2 3s, or 2 4s, or 2 5s, or 2 6s, 2 7. Yes, but that's just going to be for 1 pair.
If the 2s were taken out, it would have been times 13.
Yeah, it would have been times 13 if the 2s.
Because the 2s are already taken out. it's
There's
times
only 12 different types of pairs you can have left. Because the 2s are taken, all is to be chosen from 12 players. How many ways? If A is included, so that's a certain, A is definitely in there, but H is not. I think I did a worked example very similar to this last night. If H is not in there, so we've got 1, 2, 3, 4, 5, 6, 7. So A is definitely in there, one way to choose A. For these, you could choose from A, B, C, D, E, F, G, not H, I, J, and K. Oh, A's already taken. So we want to choose 6 more
10.
out of 1, 2, 3, 4, 5, 6, 7, 8, 9. No, out of 8.
L as well. Mrs. L as well. KL.
Okay. How many people? There's 12. So we can choose 6 more, but out of 10, because H doesn't, because we don't want H in there, I've taken H out of my set. because A is already included. They have to be included. They're already down here as being chosen. So it is 1 times 10 choose 6 for part D. In how many ways can A be included and H not be included? Now for E, if one of F and L is to be included, so either one of them, how many ways can either F or L be included? Aren't there two choices there, F or L?
It's the same as that, but you times it by 2.
Just one sec. I just want to put it out. So if F or L is in there, you've got two choices, F or L. But now F and L cannot be in the next set that you're choosing from. 1, 2, 3, 4, 5, 6, 7. So you've still got to choose 6 more players, right? So if one of F and L is to be included and the other one is excluded. So we've got F or... All right. F or L, and then there's 10 players left to choose from. Because if F is in, L is out. So you could do what you did there times 2. Or F or L, you've got two choices. Now, if F is in, L can't be in. So you've only got 10 left to choose from. So it's 2 times 10 choose 6. All right? Girls, it really helps to put something down on paper. I cannot do it without my dashes. I can't do it with little bits down here. It's just too hard to try and do it in your head. All right? Question 13. 10 points are chosen in a plane, no 3 of which are collinear. The reason they're not collinear because you can't make a triangle out of 3 points in a straight line. It says how many lines can be drawn through the points. So if you want to draw a line through points, don't you have to use 2 points every time you join a line? So aren't there 10 points altogether? So how many lines can be joined through the points? Every time you want to do a line, you choose 2 points and draw a line. You choose 2 points and draw a line. 2 points and draw a line. Okay? So how am I drawing a line? Aren't I choosing 2 points? So it's 10, choose 2. So that will tell me how many different lots of lines. I mean, I can sit here and start working them out. From this point, I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 from that point. And then I could do from this point 1, 2, 3, 4, 5, 6, 7, 8. I wouldn't include back there. It's the same line. Okay? Now, what's the answer for 10 choose 2? Because I'll tell you what it will be. You know how I just did 9 points from the first one, 8 from the second? Can someone do 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1?
45.
It should add up to that because look, whoa, there goes that folder. 9 from the first, then 8, 7, 6, 5, 4, 3, 2, 1. 9 and 1 is 10, 2 and 8 is 10, 7 and 3 is 10, 6 and 4 is 10, that's 40, 45. I could actually do it by drawing. I would get 45 because from the first dot you can get 9. From the second dot you can get 8 because you wouldn't go back to the first dot because you're repeating that path. From the next dot you'd get 7, then you'd get 6. So it's 10 choose 2 because to draw a straight line between 2 dots, you just choose 2 dots out of the 10. So it's 10 choose 2. Now, how many triangles can be drawn if each of the vertices is at one of the given points? So let's say for part B, all my triangles have to go from this point. Aren't I choosing 2 other points to make my triangle? So if my triangle has to include this point, so how many triangles can be drawn if each of the vertices is at one of the given points? So I have to choose 2 more to make a triangle, or I have to choose 2 more to make a triangle. I've only got 9 to choose from because I've definitely got one of them, so it's 9 choose 2. Now, which is, what's 9 choose 2, girl?
No, it's wrong. It's 10 choose 3.
Oh, maybe I'm misunderstanding the wording. If each of the vertices is at one of the at one of those given points. Sorry. So, girls, it's not that particular point. It's at any of those
You
points.
did the question for C.
Yeah, I just did the question for C. I miss my English is okay, but I've misunderstood. So, in other words, girls, you're just trying to form, it's like 10 choose 2. Instead of drawing a straight line, we're drawing a triangle now. So it's 10 choose 3, because to draw a triangle, you need 3 corners. So 10 choose 3 gives you the number of different triangles you could do. Sorry about that, girls, which is?
120.
Sorry, I misunderstood. Now for part C, how many triangles have a particular point as one of the vertices? That's what I was just doing. So let's say you've got that black point there as your vertice. You have to choose 2 other points to make your triangle. So you've got 9 left and you're choosing 2. So how many triangles have a particular point as one of the vertices? And it's 36. D. How many triangles have 2 particular points making up one of the sides? So now I'm going to highlight 2. So how many left? So that's one side. I just have to choose another point to make my triangle. 8 choose 1, which is just 8. Okay, got that one. Now, that's question 13. Question 14 is similar, so I'm going to leave that one for homework. But we're just going to do some more of these because diagonals are there in a quadrilateral. We know there are 2, all right, but I haven't used notation yet. For it to be a diagonal, if I'm here, see there are double ups. I can go across there, but then that's the same going back. Do you understand what I'm saying? And from here, I could go across there, but then coming back from that point is the same. I want to try and do it in C notation in a minute because we have to come up with a general pattern. But we're just going to leave it for a sec. How many diagonals in a pentagon? From this point, haven't we got 1, 2? From this point, there's 1, 2. And from here, I've already got that one. I've got that one. There's 5. Now, problem is, I still need to come up with some sort of pattern. Now, I'll just pause. First one, if you've got 4 points, it's 4 choose 2 will give you the number of combinations between them. 1, 2, and you can join these, that, and that. But the problem is the last 4 that I've joined, when I join the outsides of the shape, they're not diagonals. So that's why I take those 4 sides away at the end. With the pentagon, if I've got 5 points, the outsides of the shape, when I join those, I have to take them away because they're not diagonals, whereas I've got the other diagonals that will work. Okay? Therefore, for C, how many diagonals are there in a decagon? It will be 10 choose 2 minus 10. Get the idea? And because you have to subtract the joining the sides, minus joining the sides, minus joining the sides, minus joining the sides. And so therefore, for a polygon with n sides, it's 10 choose n minus n.
No, it's NC2 minus n.
You know what I mean. NC2 minus n. All right. Tired girls. Not living. Changed around the circle. How many triangles can be drawn with those points as vertices? You've got 12 points. Choose 3 to make a triangle. Now, how many pairs of such triangles? In other words, we want to do 2 triangles. So 12 choose how many, if I want 2 distinct triangles, if the vertices of the 2 triangles are distinct. In other words, I want a triangle here, but the other triangle cannot be on any one of those corners. So I could have another triangle. They can cross over, but as long as the corners are not the same.
So we're going to have 9.
We've got 12 choosing 6. That's just choosing the 6 points that are different. But then, so I know this is just one sec. If you want to draw 2 triangles, you have to choose 6 points. Right, that's 12 choose 6. Now, I still haven't drawn, I've only chosen 6 points, but out of those 6 points that you've chosen, says we need to form 2 triangles. Obviously, to do that, you need 6 points. So I've chosen 6 points out of those original 12 points. Now, if I want to form a triangle, let's say I start with this point. I can now choose, I've got 5 left to choose from, times 5, choose 2. So to form an actual triangle, say from this point, I've got 5, choose 2 others.
Why don't you just do 6, choose 3?
Because
Why do you have to pick one?
Okay, for part C, for them not overlapping, you've got your 6 points, and there are 3 ways. That's 1 way, 2 ways if I number the points. Joining 1, 2, 6, 3, 4, 5, joining 1, 2, 3, 4, 5, 6, and joining 2, 3, 4 and points 1, 5, 6. So there are 3 ways of forming 2 non-overlapping triangles. So it's 12, choose 6 times 3. And for part D, in how many such pairs will the triangles overlap? It would be all your pairs from part B, answer, minus your non-overlapping pairs in part C, which is that as shown. Let S be the set of the first 10 positive integers. How many subsets does S have? Now what it means, odd integers. So 19A. How many subsets? In other words, the subset you could have, you know how there are 10 integers? You want how subsets would be a group of 1 or group of 2 or a group of 3. So number of subsets of S equals a group of 1 or 2 or 3, 4, 5, 6, 7, 8, 9 or 10 numbers. They're subsets, okay?
I don't get it.
So how many subsets of S? How many smaller sets or other sets? How many sets can you make from S? So you could have a set of 1 number, a set of 2 numbers, a set of 3 numbers, a set of 4 numbers. Now, that would be 10 numbers there, choose 1, or, which means plus, you could have a group of 2, 10 choose 2. Do you get the idea? Plus 10 choose 3, plus 10 choose 4, 10 choose 5. There's a quicker way of doing this. 10 choose 6, 10 choose 7, 10 choose 8, 10 choose 9, plus 10 choose all of them, 10. Now, I'll work them out for you. It's 10 choose 1 is 10. 10 choose 2 is 45. 10 choose 3, 120. We okay with this?
Yeah.
So we've got 10, 45, 120, 210,
Also, it's
252. Guess what? 210. I want to say something. 10 choose 1 is the same as 10 choose 9. 10 choose 2 is the same as 10 choose 8. We will do this when we do binomial theorem. 10 choose 3 is the same as 10 choose 7. 10 choose 4 is the same as 10 choose 6. The reason it's the same, I haven't explained to you what choose notation is properly yet. Plus 120 plus 45 plus 10 plus 1. And you will get 1,024. Now, see, that's all the possible combinations of 1 set, 2 sets, 3 sets, 4 sets. When you learn binomial theorem, you will learn that it's 2 to the power of 10. It's always 2 to the power of n, depending on how many elements in your set. Now, until I do binomial theorem, you won't really understand that. So, just I'll